So a moment ago we drew the graph of this thing, which is, that was the picture. It's somewhat crooked, but anyways, this L is length 4. It reaches its peak at 30 degrees, and it comes back to hit the origin at 60 degrees. So the 60-degree line is like a tangent line to the graph at the origin. And therefore, this is asking us to find the area of this one petal. Now this is quite a challenge because, I mean, in Calc 2, we learned how to find the area of between a curve, right? So we were taught that if you have one curve, another curve, and then let's say this is f of x and then g of x for some domain a to b, then simply the area that's between the two curves is integral from a to b of fx minus gx dx. That's the way that we were taught. Now this is useless for us because if we actually rewrote this in terms of x and y coordinate system, it's just simply too hard. Yeah, I could try it, but that's going to take some time, and even if I succeeded, it's going to have square roots of x squared plus y squared at some place, and really, really crazy things that makes it impossible to do. Okay, so that means this approach should be abandoned completely. Instead, we'll have to do a new idea. And the idea is, remember how I explained that in the polar coordinate system, dA, which is dx dy, is same as r dr d theta. Okay, and we'll be using double integrals to figure this area out. And I was saying, this double integral had the meaning of, if you have region R downstairs and you have some kind of a surface upstairs, then the volume under the surface over this region is what this is calculating, right? So double integral calculates the volume. But here's an interesting thing that we know about columns. Columns, or sometimes known as prisms, columns or prisms are these geometric three-dimensional objects where you have some base and it just goes straight up, and all the cross sections are exactly the same. Can't make it the same, but it's supposed to be the same. So these are called columns. And the volume of a column, just like area of a rectangle is base times height, volume of the column is, if I say the base area is A and the height is H, the volume is simply A times H, because this is just being spanned up like that. Makes sense, right? Yeah, kind of makes sense. So the strategy that we're going to take is we're going to put a function over it, which is the function over this surface is just 1. So that the shape under the graph is like a column with height what? What will be the height? If f is 1, and if I look at this volume, it will be the volume of a column with height. You don't get what I'm saying? Okay. Height 1, right? Yeah, if I have f equals to 1, that's the surface over this region, right? And if I calculate the volume under the surface over this region R, that'll be the column with height 1. Therefore, the volume, when height is 1, the volume will be same as the area, right? Yeah, so that's the idea. So idea is, the central idea for doing this is volume under f equals to 1. That means that f is always 1. That's constant function. Is same as base area. So we're going to use that idea. So what we're going to do is we're going to calculate over that one petal, that one petal, that's what I'm drawing here, just one, value of 1 dA. Okay. But then calculating this is another matter. To calculate this, we need to first write down dA as r dr d theta. And that means I need to figure out what goes here and there, and also theta from here to there. Okay. Now, because it's a double integral, it still follows the same principle, which is that these two are actually equation for curves. So this really should be an r equals the function of theta, r equals the function of theta. On the other hand, these are values. It's an interval for theta. So that those are, so the language that I use is curve to curve, point to point, okay? In other words, here we put a function of theta in, whereas here I put values for theta in. And I try to explain this by painting analogy, right? So what does it mean to paint this region using R? Well, dr, think about what dr is. Dr means you're increasing in the radial direction, right? So in other words, you're always starting at the origin. You're trying to paint this radially. That's how you're painting it, okay? Now, if you paint like that, you should always provide the equation for the beginning boundary to the ending boundary, right? So what is your beginning boundary? You always start from here. So what's your beginning boundary?
0.
0. So start from 0. But then you end at this curve. That's your ending boundary, right? So what should I write here?
4 sine theta.
4 sine 3 theta. Yeah, 4 sine 3 theta. That's what you need to put in, okay? So r equals to 0 is only a point, but you should really think of this as like r equals to a function of theta where that function is a constant function, 0, okay? So although it's a point, you should really think of this as a equation of a function of theta. So it's from function to functions. But from here, theta goes from where to where in this picture? It starts from here, which is, what's that direction? Theta value?
0.
0. Okay. And what's this direction?
Pi over 3.
Pi over 3, because that's 60 degrees. 60 degrees is pi over 3. So you put pi over 3 here. Okay, so that's what we have to integrate. The initial integral is quite simple because you're integrating 1 times r is r, right? So if you integrate r, you only need, if you integrate r, you just get 1/2 r squared. And to it, you're plugging in 4 sine 3 theta and 0 d theta. Now that these values are going into r, you end up with 0 to pi over 3 of 1/2 4 sine 3 theta squared d theta. And if you simplify this, you get 4 squared is 16. 16 divided by 2 is 8. Sine squared of 3 theta d theta. Okay. Now this is one of these integrals that are not so straightforward. It requires you to know this following formula, which says sine squared of a is equals to 1 minus cosine 2a over 2. Okay. So we will have to use that formula. Yeah, I'll provide that for the exam. That's like one of those formulas that's not so frequently used, so that it's reasonable to be provided. Okay. Yeah, I usually don't provide many formulas, but for that one I will provide. Okay, so if you replace a by 3 theta and replace this entire sine squared of 3 theta by that formula, I end up getting 0 to pi over 3 of 8 times 1 minus cosine 6 theta over 2 d theta, where 8 and 2 cancel, so this is 4 and then 1. Right? That 4 can be brought outside, so that's going to be integral of 1 minus cosine 6 theta d theta, and from 0 to pi over 3. Integrating 1 is easy, that's just theta. Now, if you differentiate sine, you get cosine. So if you integrate cosine, you should be getting sine, right? But because of the chain rule, you need something in front. Who can tell me what goes in front? It's 1/6. Okay, yeah. And the formula that you need to use, maybe I should write down here, is integral of f of ax plus b dx is 1 over a capital F of ax plus b plus c. Okay. What this is something that you can easily prove by using u substitution. You just set u as ax plus b, and then you get this. But this comes up so frequently, especially in the next differential equations class. You get to use this a lot, so you may as well memorize this. Okay. What it's saying is that if you have something multiplied in front of x, then not only you just innovate f to get big F, but the reciprocal of that number in front of x should be appearing here. So, see, this 6, which is in front of theta, that's going to give you 1/6. Now, to easily see why that's true, you know how to verify an integral, right? How do you verify an integral? You just differentiate to see that you get that, right? When you get to differentiate this, look at this. 6 theta is an inside function, so you have to bring it out and differentiate for the chain rule, right? When you differentiate 6 theta, that creates 6, which cancels with this 1/6, giving you that. Okay? So it's all about foundations. If you're weak in your foundations in Calc 1 and 2, then you will still suffer in Calc 3 and again in differential equations. If you know these things well, then you're going to have an easy time doing these things, and you don't have to suffer that much. All right, so back to the calculation. That means if you plug in pi over 3, you get pi over 3 sine of 6 times pi over 3 is 2 pi. And then when you plug in 0, you get 0 in here. Sine 0 is 0, so that's all you have. Okay, what's sine 2 pi?
0.
0. So you get, this will be 0 anyway, so you get 4 pi over 3. Okay? Now, as a side note, that means the whole graph will have area what?
3 times that amount.
Yeah, which is still 4 pi.